Two fan quotations can carry different labels and still describe almost the same project. Another two can both say OEM while assigning completely different work, cost, and risk. The label is not the operating model. The useful question is, who owns each decision from product definition to after sales? Build that responsibility map first, and the right sourcing route becomes much easier to see. Treat OEM, ODM, and private label as commercial shorthand, not universal legal definitions. In this video, private label means an existing supplier platform sold under the buyer's brand. ODM means a supplier platform adapted through agreed engineering. OEM-style custom build means the factory manufactures against a buyer-controlled specification. Real contracts often blend these patterns, so define the work instead of arguing over 3 letters. Start with a 7-column responsibility matrix: product requirements, engineering, tooling and intellectual property, validation and market access, brand and packaging, change control, and lifecycle support. For every column, assign who decides, who pays, who supplies evidence, and who approves release. If a cell is blank, the project contains an unresolved assumption. That assumption will surface later as delay, rework, or a compliance gap. Private label is usually the shortest path when an existing fan platform already fits the duty point, envelope, controls, environment, and target market. The buyer mainly selects approved options: branding, labeling, documentation, and packaging. This can reduce engineering effort, but a new logo does not automatically transfer design ownership or regulatory responsibility. Verify exactly which product remains unchanged and which evidence follows the branded version. ODM becomes useful when the supplier's proven platform is close, but not exact. Changes may include dimensions, connector, cable, controller logic, mounting, impeller, acoustics, or packaging. Every change needs a controlled requirement and an impact review: airflow, pressure, input power, noise, temperature, life, safety, electromagnetic compatibility, tooling, and certificates. A small visible change can create a large validation task. An OEM-style custom build starts from a buyer-controlled specification, interface, or design package, while the manufacturer provides industrialization and production capability. Do not assume this phrase means the buyer owns every drawing, fixture, process, or improvement. Separate background intellectual property from project-created intellectual property. Then state ownership, permitted use, exclusivity, maintenance, storage, transfer, and end-of-project treatment for every tool and data set. Tooling is where vague deals become expensive. A mold invoice alone does not prove who owns the mold, who may use it, or whether it can move to another factory. Record the tool number, technical acceptance criteria, useful life expectation, maintenance responsibility, storage location, access rights, replacement rule, and transfer conditions. Apply the same discipline to firmware, test fixtures, source files, CAD, drawings, and inspection methods. Now separate product validation from market access. Performance tests answer whether the fan meets the agreed duty, noise, power, temperature, and endurance targets. Regulatory evidence answers whether the finished product can be placed in a specific market for a specific use. Responsibilities depend on the jurisdiction and product. Branding a product may carry manufacturer obligations, so identify the economic operator, applicable rules, exact product configuration, evidence owner, and document retention duty. MOQ, non-recurring engineering cost, and lead time form a triangle. Reusing a stable platform can lower engineering work and start faster. Deeper customization may require prototypes, tooling, test cycles, component commitments, and production qualification. There is no universal winner. Ask for the assumptions behind every number: forecast, batch size, approved components, drawing freeze, sample rounds, test scope, packaging, shipping, and the event that starts the lead time clock. Before production, freeze a golden sample and a release package. The package should identify the exact bill of materials, drawings, firmware, labels, packaging, inspection plan, test limits, approved deviations, and traceability format. Then create a change control path: who may propose a change, what evidence is required, who approves it, and when old stock becomes obsolete. A quiet component substitution can invalidate performance evidence even when the fan still looks identical. After-sales responsibility belongs in the sourcing model, not in a later email. Define warranty evidence, failure analysis ownership, response path, spare parts horizon, repair versus replacement rules, serial or batch traceability, field change authority, and end-of-life notice. Also define what happens if the supplier, tool, component, or regulation changes. The strongest agreement is not the longest, it is the one that leaves no critical handoff dependent on memory. Use this decision sequence. If a proven platform meets the requirement unchanged, evaluate private label. If the platform needs bounded supplier-led adaptation, evaluate ODM. If the buyer must control the specification, interfaces, and product roadmap, evaluate an OEM-style custom build. Then ignore the label and audit the matrix, responsibilities, evidence, ownership, approvals, changes, and lifecycle support. Choose the model whose documented control matches the risk you can carry.